Okay, let's try this problem. Calculate the pH of a 0.03 molar solution of acetic acid at 25 degrees. They give us the Ka for acetic acid as 1.8 times 10 to the minus 5. So the first question in your head is, what do you have? It's clear that you have an acid. They told you you have an acid. And so you ask yourself, is this a strong acid? Is it a big 6 acid? No, acetic acid is not a strong acid. It's not clibberclonoso. It's a weak acid. Therefore, that's why they gave you the Ka. So the plan of attack, if you have a weak acid, put the acid in water, ice it with a Ka. So let's take our acetic acid and put it in water. HC2H3O2 plus water. It dissociates a little. We use equilibrium signs. It gives off some of its H+. We get hydronium, H3O+, and the acetate ion will be left behind. We took our acid in water. Now we're going to go ahead and ice it. ICE. The initial concentration of my acid is 0.30 molar. We don't have any original H3O+ or original acetate in there before this dissociates. We're going to take away X, we're going to add X, we're going to add X. All right, now at equilibrium, acetate is X, the hydronium is X, and since our equilibrium constant is very small, 1.8 times 10 to the minus 5, we're going to be able to use the rule of 100 approximation where we drop the X term. It's going to be so small compared to our initial acid value. So this is a 0.30 molar solution. Now we have our equilibrium values. We put our acid in water, we iced it. Let's use our Ka. The Ka expression is our products, hydronium, H3O+ to the first power, acetate, C2H3O2- to the first power, all over are the acetic acid, HC2H3O2 regular. We leave out the water. Now we're going to go ahead and plug in all the values we know. The Ka for acetic acid is 1.8 times 10 to the minus 5. That will equal X times X, or X squared, all over 0.30. So we're going to multiply both sides by 0.3, and then to find our X, we're going to take the square root. If you go ahead and resolve this equation for X, X turns out to be 0.0023 molar, or we can write it in scientific notation as 2.3 times 10 to the minus 3 molar. So now we have our X. The next question is, what is X? If you look at your ICE table, X is your hydronium, X is your H+. So we can use that in order to get our pH. Let me get this away and we'll make some more room. pH is negative log of the H+ or hydronium value. pH here is going to be negative log of 2.3 times 10 to the negative 3. The pH value, therefore, I know is going to be very close to 3. It's going to be between 2 and 3. And when you plug that into your calculator, exactly, you get 2.63 for the overall pH. And then we ask ourselves, does that make sense? Well, we had a weak acid. This is an acidic pH. Yeah, it makes sense. I hope that helps. Take care.